Good afternoon, everyone. Our project is about low-cost weapon detector. Let's go, Team Victory! Let's get this, big boys!
Hello all. I would like to take this time to introduce and explain exactly what is a low-cost non-contact weapon detector. A weapon detector works by using electromagnetic waves to detect whether a person is carrying some sort of weapon, whether it be a gun, a knife, or explosive. It goes through clothing, so it can even detect concealed weapons as well. The phrase low cost means that it is cheap to produce and made of inexpensive materials, allowing it to be easily produced in mass quantities and in the hands of the people that need it most. It is simple to use and works similar to a radar gun. All it takes is to point, aim it, and pull the trigger. It has a wide variety of applications, some of the most common being in the defense industry and in prison environments, where determining if someone is a threat can mean life or death. Our goal is to introduce new ideas that can advance the current conventional weapon detectors that already exist to meet the demands of modern day.
Why are non-contact handheld weapon detectors needed in society? Non-contact handheld weapon detectors are needed because it allows law enforcement to determine if a threat is present quickly. Subjects include handguns and knives commonly associated with terrorism and gang violence. Handheld weapon detectors allow users to search a target without invasive pat-downs, also known as stop and frisk. In addition, the small detectors are more flexible than the large doorway detectors commonly found in airports and courthouses. Furthermore, the small size of the handheld device makes it discreet and hard for offenders to plan around. This new technology will act similar to radar guns used by traffic officers to measure the speed of cars. The non-contact device will ensure public safety by providing vital information. Overall, non-contact handheld weapon detectors will become increasingly common due to the evolving technology becoming more compact.
Hello, I would like to discuss the physics and the basic theory behind a weapon detector. It works using many laws of physics we learned, such as Faraday's law of induction and the Lenz's law. Faraday's law of induction states that a changing electric current produces a magnetic field, and a changing magnetic field produces an electric current. In our case, we are using Faraday's law to produce an electric current with a changing magnetic field. Lenz's law is used to determine the direction that the current will flow, and it gives use the right-hand rule. The detector, the transmitter, produce a changing electromagnetic field, creating eddy currents as a result. In this slide, I'm going to introduce the weapon detector working diagram. In this first box, we have three components: the coil, the high-frequency oscillator, and the high-frequency detector. The way these components work is that the circuit creates a high-frequency signal, and it passes through the coil, which transmits it to the target. Then the coil receives the signal that was reflected from the target and back into the circuit. In the next section deals with we can see that there is a power amplifier which amplifies the signal to allow it to reach the target successfully. The audio oscillator is what creates the buzzing sound to alert us when a weapon was detected. Beep, 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 beep.
Alright, so everything that Zilvin just said is a general idea of a weapon detector. And I'm going to talk about the pros and cons for the weapon detectors. But first, as we all know, there are two different kinds of detectors that we have nowadays: handheld metal detectors and walk-through model weapon detectors. Handheld metal detectors are much cheaper than the walk-through model. They are used to identify metallic objects that are considered to be potentially dangerous. Walk-through models are more convenient and efficient to use in government and companies' buildings. They are also commonly used in airports. Although these two types of detectors are really useful, there are still lots of disadvantages of these detectors. These detectors are lacking privacy, intrusive, and taking lots of time and manpower to use. They also have accuracy issue, false alarms on jewelry, watch, and cell phones. They can have effects on surgically installed metal devices, such as pacemakers. There are still lots of issues that we haven't found yet, but we already have some ideas and improvements to overcome some of these issues, which Hao will continue talking about in specific details.
From here, I will introduce our first improvement on transmitter and receiver of weapon detector. As we all know, even the simplest weapon detector have transmitter and receivers. So we can do some improvement on that first. We can redesign based on what transmitter will say and what receiver will get back from the target. We can change the frequency to get some different things. For example, the very low frequency weapon detector will get a large range, which is very useful on small and medium objects like handgun and coins. If we change this to plus induction, its penetrability will be much better. But this is usually useful to find the gold mine. Also, we can change the wavelength and the frequency together to receive a better result, like microwave and millimeter wave. With these two new ranges, we can receive more details from the target. We can generate an image, and it will be much easier to find weapons even with plastic handgun and explosive. Now we get the image for a security person to see. With this image, we can do something more, and Charlie will give this introduction.
Thanks for Hao's introduction. Now I will introduce the improvement of the processor for you. After receiving these images, the processor needs to remove the noise and determine whether there is a weapon in the image. So we can get this target by using deep learning. Deep learning is a bunch of machine learning. The input picture will go through three parts: digital picture, design mode, and the training. These behaviors are all running on artificial neural network. Here, we will use one of the commonly deep learning modes, generative adversarial network. The GNN mode consists of two important parts, the generator and the discriminator. The purpose of the generator is to cheat the discriminator by generating data. The discriminator will judge whether this information is true or false. Firstly, we fix the discriminator and continuously training the generator, and improve its ability to dissolve the discriminator. In the second stage, we will fix the generator and training the discriminator to improve its ability to distinguish false information. By looping these two stages many times, the performance of the generator and the discriminator will be stronger and stronger. Finally, we will get the discriminator, which can be able to accurately determine whether there is a weapon in the picture. About the future, the next speaker will give you more details.
The future of weapon detectors. The area of weapon detection that has the most potential for improvement is the imaging. We looked into millimeter wave imaging in particular, as its current form has flaws. The basic idea behind millimeter imaging is that scanners direct a narrowband millimeter signal at the target and then interpret the reflected energy. This is done by having a wave source illuminate the target through an aperture. The reflected signal is recorded by a receiver or detector, and the data is digitized. An algorithm then reconstructs the data to form an image. So currently, there are two methods to accomplish this. One method has a signal source and sets up the millimeter detectors in a grid formation behind a large lens to detect the reflected signal. The problem with this method is that the aperture is small, leading to a limited field of view. The cost for the grid of detectors is also quite high. Now, the other method sets up a linear chain of transmitter receivers that are switched on sequentially over a large aperture. The phase and amplitude of the reflected signals are recorded, which are then used by the algorithm to reconstruct the image. While this method has a large field of view, targets with substantial depth can't be fully focused due to the close range on the aperture. The human body, for example, has too much depth to be fully imaged this way. So the future of weapon detection imaging would be to remove these disadvantages. One experimental idea to improve the current methods is called wideband imaging.
The new method improved imaging. Instead of narrowband imaging plan, an experimental plan is to use wideband imaging. It focuses fully 3D image from the data, while the current methods only reveal 2D image at variety of frequencies. The way this works is a wideband diverging signal is focused through an aperture onto the target, and then the reflex signal is recorded by the receiver, and then the data is mathematically converted by an algorithm to reveal the 3D image. As you can see from the pictures, the wideband imaging has much clear result. The method is not perfect. However, due to high cost and large size of technology, the next step would be to look into how we can modify the technology to implement it in low-cost, compact weapon detector.
In the following slide, it will be about a summary of the weapon detector, including the developments like how such a simple device metal detector can be upgraded to become a weapon detector. Also, moving toward the future, like what the newest research currently happening right now. Now let's get into the non-contact metal detector in theory base. The coil inside the metal detector will generate a fixed magnetic field B naught. When the fixed magnetic field B is near the metal object, it will generate the eddy current. This current will create an opposite direction magnetic field B naught based on the Lenz's law. So the B naught will interface with the B, and this is how the alarm system will start warning the user. This theory sounds really basic and easy, however, this is not perfect, such as false accuracy and non-medical device friendly. That it has to upgrade to become a weapons detector, such as radar weapons detector, which has higher precisions and wider range with different frequencies. Also, it's helpful using microwave and millimeter wave, which allow the detector to detect higher frequencies. Moreover, the application of AI into a weapon detector can help to reduce the noise and improve the accuracy. So having all these additional features can recover the downside of the metal detector and protect the system. Finally, looking into the future, our team has discovered there's more research and invention on the weapon detector. For example, research on the improvement of the image transmissions. Also, applying new method, wideband imaging, which allow to have a high resolution of the image after transmissions. Therefore, nothing is perfect. Researchers are always looking for new solutions to improve our device.